proposal for the 2008 ARC Fault Circuit Interrupter, or AFCI, requirement did indeed pass the final draft and was subsequently incorporated into the 2008 National Electrical Code, or NEC. This inclusion marked a significant advancement in electrical safety standards for residential construction. The core of this requirement mandates the installation of AFCIs in all new residential construction projects. This means that any newly built home, apartment, or similar residential dwelling must have AFCIs installed as part of its electrical system. However, the code recognizes that certain areas within a residence present different electrical risk profiles and, as such, provides specific exceptions to the blanket AFCI requirement. These exceptions are explicitly defined as bathrooms, kitchens, garages, and unfinished basements. In these locations, the requirement for AFCI protection is either reduced or altogether waived, depending on the specific circumstances and the version of the NEC being applied. Understanding the scope and limitations of this AFCI requirement is crucial for electrical contractors, builders, and homeowners alike. It ensures compliance with the NEC and contributes to a safer living environment by mitigating the risk of electrical fires caused by arc faults. An arc fault is an unintended electrical discharge that occurs when electrical current jumps between two or more conductors. These faults can generate intense heat, which can ignite surrounding materials and lead to a fire. AFCIs are designed to detect these arc faults and quickly interrupt the circuit, thereby preventing a fire from starting. The technology behind AFCIs is based on sophisticated electronic circuitry that can distinguish between normal arcing, such as that which occurs when a switch is opened or closed, and dangerous arc faults. This differentiation is essential to prevent nuisance tripping of the circuit breaker. AFCIs continuously monitor the electrical waveform for characteristics that are indicative of arc faults. These characteristics can include erratic current flow, high-frequency noise, and other anomalies. When an AFCI detects an arc fault, it quickly trips the circuit breaker, cutting off the flow of electricity and preventing the arc fault from escalating into a fire. There are two primary types of AFCIs: branch circuit AFCIs and combination AFCIs. Branch circuit AFCIs provide protection against parallel arc faults, which occur between two different conductors, such as a hot wire and a neutral wire, or a hot wire and a ground wire. Combination AFCIs, on the other hand, provide protection against both parallel and series arc faults. Series arc faults occur within a single conductor, such as a broken or frayed wire. Combination AFCIs are generally considered to provide a higher level of protection than branch circuit AFCIs, and they are now the standard requirement in most jurisdictions. The installation of AFCIs is generally straightforward, but it is important to follow the manufacturer's instructions and all applicable electrical codes. AFCIs are typically installed in the electrical panel, replacing standard circuit breakers. They have a test button that allows the homeowner or electrician to verify that the device is functioning properly. It is recommended to test AFCIs monthly to ensure that they are providing continuous protection. When selecting AFCIs, it is important to choose devices that are listed and labeled by a recognized testing laboratory such as Underwriters Laboratories or UL. This ensures that the devices have been tested and certified to meet industry safety standards. It is also important to select AFCIs that are compatible with the existing electrical system. The 2008 NEC requirement for AFCIs has had a significant impact on electrical safety in residential buildings. Studies have shown that AFCIs are effective in reducing the risk of electrical fires caused by arc faults. By detecting and interrupting these faults, AFCIs can prevent fires from starting, saving lives and property. The exceptions to the AFCI requirement, bathrooms, kitchens, garages, and unfinished basements, are based on the specific electrical characteristics of these areas. For example, bathrooms and kitchens are often subject to moisture, which can increase the risk of ground faults. Garages may contain flammable materials such as gasoline and oil, which can be easily ignited by an arc fault. Unfinished basements may have exposed wiring and other electrical hazards. While AFCIs are not required in these areas, other safety measures, such as ground fault circuit interrupters or GFCIs, may be required to provide adequate protection. GFCIs are designed to protect against ground faults, which occur when an electrical current flows through an unintended path to ground. Ground faults can be caused by moisture, damaged wiring, or faulty appliances. AFCIs quickly interrupt the circuit when a ground fault is detected, preventing electrical shock. The NEC specifies the locations where AFCIs are required, such as bathrooms, kitchens, and outdoor areas. The combination of AFCIs and AFCIs provides a comprehensive approach to electrical safety in residential buildings. AFCIs protect against arc faults, while AFCIs protect against ground faults. Together, these devices can significantly reduce the risk of electrical fires and electrical shock. It is important to know that the NEC is updated every 3 years, and the AFCI requirements may change over time. Electrical contractors, builders, and homeowners should stay informed about the latest code changes to ensure compliance. The NEC is a comprehensive document that covers all aspects of electrical installation. It is essential to consult the NEC and any applicable local codes before performing any electrical work. Proper electrical installation is crucial for ensuring the safety of occupants and preventing electrical hazards. In addition to the AFCI requirements, the NEC also includes requirements for other safety devices, such as smoke detectors and carbon monoxide detectors. Smoke detectors are required in all sleeping areas of residential buildings, and carbon monoxide detectors are required in homes that have fuel-burning appliances or attached garages. These devices provide early warning of fires and carbon monoxide poisoning, allowing occupants to escape safely. Electrical safety is a shared responsibility. Electrical contractors, builders, and homeowners all have a role to play in ensuring that electrical systems are installed and maintained properly. By following the NEC and other applicable codes, and by using qualified electrical professionals, it is possible to create a safe and reliable electrical environment. The 2008 AFCI requirement represents a significant step forward in electrical safety. By mandating the installation of AFCIs in new residential construction, the NEC has helped to reduce the risk of electrical fires and protect lives and property. While the exceptions to the AFCI requirement should be understood, the overall goal is to provide a high level of electrical safety for all occupants of residential buildings. Furthermore, understanding the practical implications of the 2008 NEC update concerning AFCIs extends beyond mere compliance. It involves a deeper comprehension of the technology, its limitations, and its integration into existing electrical systems. For instance, the selection of an appropriate AFCI device requires careful consideration of the circuit characteristics. Factors such as the load type, wiring configuration, and potential for nuisance stripping must be evaluated. Some appliances, particularly those with motors or electronic components, can generate electrical noise that may trigger an AFCI unnecessarily. In such cases, specialized AFCIs designed to tolerate these conditions may be required. Additionally, the proper installation of AFCIs involves more than simply replacing a standard circuit breaker. It requires a thorough understanding of the wiring system, including grounding and bonding practices. Improper grounding can compromise the effectiveness of AFCIs and increase the risk of electrical shock. Therefore, it is essential that only qualified electricians perform AFCI installations. Beyond the technical aspects, there are also practical considerations for homeowners. AFCIs, like any electrical device, can fail over time. Regular testing is crucial to ensure that they are functioning properly. Homeowners should be instructed on how to test their AFCIs and what to do if they fail. Moreover, homeowners should be aware of the potential for nuisance tripping. If an AFCI trips frequently, it may indicate a problem with the circuit or the appliance connected to it. In such cases, a qualified electrician should be consulted to diagnose and resolve the issue. The 2008 NEC update also prompted changes in the manufacturing of electrical equipment. AFCI manufacturers have continuously refined their designs to improve performance and reduce nuisance tripping. They have also developed new types of AFCIs that are better suited for specific applications. These advancements have made AFCIs more reliable and easier to use. The impact of the 2008 AFCI requirement extends beyond residential construction. It has also influenced the development of electrical safety standards for commercial and industrial buildings. While AFCIs are not yet widely required in these settings, there is growing recognition of their potential to reduce the risk of electrical fires. As technology advances and costs decrease, it is likely that AFCIs will become more prevalent in commercial and industrial applications. Furthermore, the 2008 AFCI requirement has spurred research into the causes of electrical fires. By analyzing data on arc fault incidents, researchers have gained a better understanding of the factors that contribute to these fires. This knowledge is being used to develop new strategies for preventing electrical fires, including improved wiring practices, more robust electrical equipment, and more effective fire detection and suppression systems. In addition to the technical and practical aspects, there are also economic considerations associated with the 2008 AFCI requirement. The cost of AFCIs can add to the overall cost of new construction. However, this cost must be weighed against the potential cost of an electrical fire, which can include property damage, injuries, and even death. Studies have shown that AFCIs are cost-effective in the long run, as they can prevent fires that would otherwise cause significant economic losses. Moreover, the 2008 AFCI requirement has created new opportunities for electrical contractors and manufacturers. The demand for AFCIs has increased significantly, creating new jobs and stimulating economic growth. This has also led to increased competition among manufacturers, which has helped to drive down prices and improve product quality. The 2008 AFCI requirement is not without its critics. Some argue that AFCIs are unnecessary and that they add unnecessary costs to new construction. Others claim that AFCIs are prone to nuisance tripping and that they can be difficult to troubleshoot. However, these criticisms are largely based on anecdotal evidence and outdated information. The vast majority of studies have shown that AFCIs are effective in reducing the risk of electrical fires and that they are a valuable safety device. In conclusion, the 2008 AFCI requirement represents a significant advancement in electrical safety standards for residential construction. By mandating the installation of AFCIs in new homes, the NEC has helped to reduce the risk of electrical fires and protect lives and property. While there are some challenges associated with AFCIs, the benefits far outweigh the risks. As technology advances and costs decrease, it is likely that AFCIs will become even more prevalent in the future. The 2008 AFCI requirement underscores the importance of continuous improvement in electrical safety standards. By staying informed about the latest code changes and by using qualified electrical professionals, it is possible to create a safe and reliable electrical environment for all. Electrical safety is a shared responsibility, and everyone has a role to play in preventing electrical fires and electrical shock.